So last time what we have seen is the maximum principal strain theory, in which we have seen that if the maximum strain is going to exceed to the strain which has been developed, then the failure will occur. Now, if you don't have any problem related to all other or above theories, then just we'll move further. We'll see this next theory, that is fourth theory. This we have seen for last time, the previous one. Okay, next theory is maximum strain energy theory. Okay, that is also called as Hikes theory. Okay, which is proposed by the Hikes, and this is based on the energy which has possessed in any material. So strain energy, when we are going to say the strain energy, what this theory suggests is that total strain energy, that is in multi-axial loading, that is in our case, where actually practically forces are applied. Okay, that should, if it gets exceed or if it's become more than the strain energy, which is we have calculated or we have extracted from the simple tensile test. If it gets exceed than the strain energy in the simple tensile test, then material will get fail. Otherwise, if it is not exceeding, then material is safe. Okay. This is what we can say the total strain energy in the material. If it gets exceed than the strain energy at the yield point, then material is going to get fail. So for all other theories, previous theories which we have seen, what we have done, we have compared these theoretical results with the practical results which we have got from the simple tensile test, right? So according to this theory, the failure or yielding occurs at a point in a member when strain energy in that component per unit volume. Now, while you are going to calculate the strain energy, we are going to calculate it per unit volume, because that volume when we are going to consider then and then only. Otherwise, if you are going to calculate the strain energy, that will become for that particular component. Okay, and for that material or any component which is manufactured from that material, for that case we have to generalize this equation, and that's why strain energy is calculated per unit volume. Okay, in biaxial stress system reaches the limiting strain energy, that is strain energy at the yield point per unit volume, then failure will occur. Okay, where you are going to find this strain energy? That strain energy is calculated or find when the simple tensile test is conducted with the UTM. Okay, so this is what the statement of this theory, that is 1, 2, 3, fourth theory. Okay, any problem? Now question is that how to calculate the strain energy. The strain energy is calculated by one simple way, that is nothing but the strain energy per unit volume is calculated by means of this area under curve on stress strain curve. Now this strain energy we are going to calculate. 4 people entered waiting room. Okay, admit all. Okay, strain energy is calculated by means of calculating the area under the curve of stress strain curve. Now the stress strain curve, which we are going to see here, yes, here. This is simple stress strain curve. That is nothing but the curve which we have drawn at the time of tensile test. Okay, for ductile material, this is what the curve which we are going to get, right? And that again we are going to calculate up to yield point only. That is nothing but sigma y. After that, yielding starts, and then that we are going to consider as a failure. That's why we are not going to consider that region, that area. So here only up to, this is stress, this is strain. So stress strain curve, this is simple stress strain curve. Okay. So strain energy per unit.
Voice is not audible, sir. Hello, sir. Voice is not audible, sir.
Can you listen me?
Yes, sir.
Okay. So this strain energy is calculated based on this stress strain curve. Okay, this is graphical method by means of which we are going to calculate it. Otherwise, simply what you can do mathematically, average of stress multiplied by strain, that will be the strain energy. Average, while you are going to calculate average, you are going to divide it by 2. Okay, mathematically, when this is what graphically we are going to say. Okay, graphically, approximately it is a triangle, and area of triangle is half of the base multiplied by height. Am I right? So height of this triangle is sigma y, and base of this triangle is epsilon y, because we are going to consider this point as a yield point. Getting me? By this means, that means graphically and theoretically, that is mathematically also you can calculate the strain energy per unit volume. Okay. While you are taking average, what will be the strain energy at initial point? It is 0 point. While you are going to take the average, what you are going to write? Maximum strain energy, which is equal to sigma y multiplied by epsilon y plus initial strain energy, that is 0 divided by 2. Same equation you are going to get here, this equation. Got it? See, you can write your comments if you have any doubt. If not, you can just write yes, we can move further. Writing comments, does it mean that you are not listening me? No doubt. Okay, yes. Shubham, what? No doubt or your doubt? Okay. So once you calculate the strain energy theoretically, just what we have to do is that you have to calculate it practically also, and you have to just compare it. Practically means when we are going to conduct test with UTM. Now this previous test, this we have calculated from the test which we have conducted with the UTM, and strain energy per unit volume in case of triaxial loading system is given by half of the strain energy in x direction plus half of the strain energy in y direction plus half of the strain energy in z direction. Now this is for the 3 dimensions. We are not going to consider 3 dimensions. So straight away you write this sigma 3 and epsilon 3 value 0. Okay, in this equation. So epsilon 1 is calculated as 1 over E, sigma 1 minus mu into sigma 2 plus sigma 3 for triaxial. These equations we have written for the triaxial strain. Okay, and this first equation we have drawn for the triaxial strain energy. So in this case, if you are comparing it for the, or if you are taking it only for the 2 dimension, just put value of sigma 3 as a 0. So we can get this epsilon 3 also as a 0 in that case, and we'll have only 2 equations. That is this equation. In this case, sigma 3 will be 0. So equation which we have seen for the third theory, that is principal strain energy theory. Okay, not energy, principal strain theory. So that value will get, and that will be epsilon 1 is equal to sigma 1 over E minus mu into sigma 2 by E. Same equation we have written for third theory, right? Here also we'll get the value of sigma 2 in the same way, that is sigma 2 by E minus mu into sigma 1 by E. Right? And this equation is going to become 0. Now this total strain energy per unit volume, as we are going to calculate it per unit volume, that's why we have taken it for the 3 dimension. Okay. So while we are considering only biaxial stress system, third quantity is going to become 0. Okay. So in this case, we put value of sigma 3 equal to 0, and this sigma 3 also will become 0. This sigma 3 also will become 0. So equation will be 1 by 2E into bracket sigma 1 square plus sigma 2 square minus mu into sigma 1 multiplied by sigma 2. Okay. This equation, we'll call it as equation 2. We have to compare with the previous equation which we have calculated from simple tensile test. Okay. And if this value, this strain energy per unit volume, exceeds than the value which we have calculated in simple tensile test, if it gets exceed, this value gets exceed than the previous slide value, then failure is going to occur. Okay. Now let me ask one question, that this equation, if we are going to take this 2E to the other side, which type of this equation is x square plus y square minus constant into x into y? Are you remembering which equation it is? What we can indicate by this equation? Mathematically, I will say that x square plus y square minus a xy is equal to b. B is the constant. This last equation which I have written here, this 1 over 2e will take to the other side. That is constant.
A plus B bracket square.
A plus
B bracket square.
b, is it plus?
No, sir. A minus B bracket square.
A minus b bracket square. Don't say A or B. It is x minus y. A and B is constant that we have used. X and Y are variables. Here sigma 1 and sigma 2 are the variables. Variables means they are changing their value. We can change it, okay? But mu value we cannot change for that material. Even E value for that material cannot be changed. Even strain energy per unit volume for that particular material cannot be changed, right? So that's why we are considering it as a constant. So x square minus y square is equal to constant A. So yes, this equation is this type. But what indicates by this equation? X square, or in other words, x square plus y square minus mu into xy equal to A. Which type of line or curve or what is indicated by this equation? Hyperbola, parabola,
Ellipse, sir.
ellipse. Ellipse is indicated by this equation, and this equation is going to give us ellipse. So in previous case, what this diagram I have copied, actually not drawn, because it is drawn with scale, okay? And from the equation which we have derived, we are going to get this ellipse. So previous second theory, that is the maximum strain, sorry, maximum shear stress theory is going to give us this type of curve, if you are remembering. Am I right? And this theory is going to give us this ellipse. So most of the points which are covered in second theory, that is the shear stress theory, maximum shear stress theory, has covered in this strain energy theory. Am I right? So it is more ever closer to the second theory, and that's why this theory is used for ductile materials. Any doubt? Hello?
Yes, sir.
Do you have any doubt? कोणाला काही शंका आहे का? Next theory we'll see to the next lecture. I think your next lecture will start soon. Due to electricity, our lecture was started late. So you can write your roll numbers in chat box, and you can leave this meeting. Thank you for listening. You have to put your roll numbers. Mahesh Bangar. Have you written your roll number? Bangar. Mahesh Bangar. Sadashiv Bangar. Okay, you can leave meeting, Mahesh. Muntasim. Muntasim, have you written your roll number?